Let's look at the third question. Plugging into MassHunter, Quant, and Qual. That involves a vision of a centralized analysis where the data is funneled into MassHunter. And you may ask, without going into technical details, what are the salient features of MassHunter that make it attractive? Well, I'll answer that by pointing out that there are two main applications. There's Quant and Qual. Quant is the mainstay of the LC and GC triple, where data is often collected as MRM, and that parallels the situation with the single, where quantitation data for target analysis is collected in the SIM mode. In contrast to that, Qual, which is a discovery tool, is often using scan data because you're looking for information, discovering information, and that's especially important in the method development for the quantitation method. Let's try on another generalization. Batch at a glance is designed to handle a group of samples together. And in that regard, batch at a glance is considerably different than the GCMS ChemStation in its paradigm. Now, I'd like to observe that a one-to-one mapping of features between the GCMS ChemStation and MassHunter is difficult because of that paradigm shift. In contrast, Qual is often used with single samples in its discovery mode, and it provides a set of tools to slice and dice into that chromatogram. Batch at a glance is about the relationships between these groups of samples, and an important relationship is the CALs and the QCs, which build a quantitation table which is then applied to the samples. In addition to that, integrated into the Quant application are outliers which assist in evaluating the batches, which turns out to be often a bottleneck in the lab's productivity. In contrast, Qual, as mentioned, has spectral tools, and for the triple certainly, Qual is the place where you would end up doing the method development to discover the ions and the transitions that would end up in the Quant method. Let's take a step back and look at the corresponding GCMS ChemStation lineage. If you look at the ChemStation features, which were often used for target compound analysis, there's a strong similarity between those features and the features you will find in batch at a glance quantitation. In contrast, when you move over to Qual, you may be familiar with the tool set of AMDIST and the NIST library. Now in MassHunter Qual, we still support calling the NIST tools and of course support the NIST.L libraries. But the deconvolution and library search components in both Quant and Qual are fully integrated into the application, and that enables quite a bit more sophisticated automation. To demonstrate that these components are shared, let me point out that unknowns analysis in Quant, which is basically the automation of deconvolution and library search for compounds that are beyond the target list, shares the same deconvolution and library search approach which is used in Qual, and that in Qual offers the spectral manipulation which is used when curating the spectra for library entries when you're creating your own library. A reward for migrating to MassHunter is that MassHunter employs new technology. And for example, without going into the technical details, it is advantageous to use new technology in a number of ways. For example, MassHunter stores the results in an in-memory database called a dataset. Also, reporting results are generated in an XML document. Qual employs similar technology. These tools enable easy integration with modern databases and other components, which I'll demonstrate in a moment. MassHunter ships with a component that is called Excel from Microsoft, and we use Excel extensively as a formatting engine, and Excel delivers a familiar yet powerful engine. The latest version of Excel provides numerous advantages which are discussed in detail in other video demos. So in conclusion, I hope you consider migrating to MassHunter software for your future needs, and I'd like to thank you for your attention.